Hello and welcome to this video about the basic EOQ model. I just want to walk you through the model setup and implementation in Excel in this video. As usual, what we start out with is a set of given parameters, most importantly lambda, which is annual demand, in this case 3,000 units per year. We have an order placement cost of $2 per order. The inventory carrying charge I is 30% and the unit value is C, $10. So that tells us that the inventory holding cost per unit per year, which we call H, is simply equal to I times C, or in other words, $3. For now, we assume that the order quantity is 20 units. This, of course, is subjective. We will try to find out if this really is the cost minimizing order quantity, or in other words, the EOQ. What we see next in this sheet here is the total cost function as we discussed it in class. Total costs are the sums of purchase costs plus the inventory holding costs plus order costs. Now I included purchase costs here only because it becomes relevant when we talk about quantity discounts. In the case of quantity discounts, not only will inventory holding costs and order costs be affected by quantity discounts, but also the purchase costs will be affected. In the basic EOQ model, which is what we talk about here, purchase costs do not make a difference because they are independent of the order quantity. When we talk about quantity discounts, purchase costs are actually also a function of the order quantity, which is why I left it in here just for completeness. So what we're going to do is we're going to implement these formulas in Excel. So the annual purchase cost simply equals lambda annual demand multiplied with the unit cost C, or in other words, $30,000 per year. Likewise, the inventory holding costs simply equal to our average inventory, which is Q divided by 2 multiplied by the inventory holding cost per unit per year H of $3. So for an order quantity of 20 units per order, we would have a total annual inventory holding cost of just about $30. Our annual ordering cost then is simply the number of orders we will place over the course of the year, lambda divided by Q multiplied by the cost of placing a single order, which is K, in this case $300. G of Q, our total cost, then, is the sum of these cost components. And again, for now, I will simply ignore purchase costs and focus on inventory holding costs and ordering costs only. So my G of Q will simply be annual inventory holding costs plus the annual ordering costs for a total of $330 per year. Now we can compute the EOQ by using a formula we know. It is the square root of 2 times annual demand times the cost of placing an order divided by the inventory holding cost per unit per year H. And it gives us, in this case, an EOQ of 63.25. That will be the optimum solution. We can obtain this same value differently by using Solver. Let me show you how to do this now. We can go to Data and find Solver. When you open Solver, make sure all the cells are empty before setting up the numerical optimization by hitting Reset All. The idea is to have Excel help us find the value of Q that will minimize total costs. So our target cell is G of Q. It is our total cost that we want to have minimized. So we click on Minimize, and then we want to change the order quantity Q such that we receive or obtain minimal total costs. So this defines our optimization problem. Now we just click on Solve, and Excel, not surprisingly of course, finds a value of 63.25 as the economic order quantity, the order quantity that minimizes total cost. In this case, we see our G of Q would be down to $190 per year as opposed to $330 with an order quantity for 20 units. Now let me reset this to 20 units for now, and let's take a look at this data table to the right here. What we're going to do is we're going to compute annual inventory holding costs, AIHC, and annual ordering costs, AOC, as a function of different values of order quantities. So for 20 units per order, we already know that the annual inventory holding cost will be $30, and likewise for an order quantity of 20 units, the annual ordering cost will be $300. So the sum of those two, our G of Q, would simply be $330. Now we're going to complete a data table. The way we do this is we simply highlight the entire table, and then we go to Data What If Analysis, Data Table, and we leave row input cell empty, and for column input cell we put Q, or in this case 20 units. And what Excel does automatically is it calculates the inventory holding costs and annual ordering costs as well as the total cost, G of Q, for every possible order quantity between 20 and 100. And again, of course, we see that at the EOQ of about 63 units, we obtain the minimum total cost of $189.74. Now, let me just graph this for you. Again, the way we do this is we highlight the entire table, and then we go to Insert Line Graph, and we select a 2D line graph. Once the graph comes up, we will reformat the graph to make it a little more readable. To do this, we simply right-click on the graph and click on Select Data, and we're going to remove Q from the graph. And we're going to edit the horizontal axis because we want Q to be our x-axis label. In the x-axis box, we highlight the order quantity column from 20 to 100. Then we hit OK. And now we see the graph show us Q increasing from 20 to 100. We can now see graphically that our average inventory holding costs increases, and likewise our total annual ordering costs decrease as the order quantity increases because we will be placing fewer orders. The sum of these two components then is my total cost, shown in purple. And again, we see that at an order quantity of about 63, we will minimize total costs. It happens to be the point that annual inventory holding costs and annual holding costs are actually equal. This concludes our demonstration of the basic EOQ model. Please be sure to ask me if you have any questions.